Hi and welcome along to this video today where we're going to be talking about the chain rule. This is the fourth video in the series for P1 Maths for differentiation. So the chain rule is used to differentiate composite functions. So if you're not sure what a composite function is, you need to maybe go back to the videos back in the functions topic where we talk about what a composite function actually is. So little definition here, a composite function is the result of combining two or more functions. So here I've got what the chain rule actually is. dy dx is dy du times du dx. Now that's just not going to mean anything right now, but I'm going to show you how it works with a few examples. You'll see though, just looking at this, that these derivatives over here are kind of behaving like fractions. You can see that on the right hand side, if I cancel out the du's, then we'll be left with dy dx, which is the same as the left hand side. I just wanted to emphasize here that you can use different letters for doing derivatives. In the past we've only used y and x, and we've had dy dx is the derivative of the function y with respect to the variable x. Well, you can have different letters. So here I've got the area of a circle, pi r squared, and we want to know dA dr. So really what that's saying is what is the derivative of this function a with respect to this variable r. Okay, so we're using the same rules of differentiation, but when I say dA dr, I'm really saying the derivative of a with respect to r. So the same rule applies. We put the number down the front, we subtract 1 from the power. Pi is just a number, so we've got 2 pi r. So the derivative, yes, is the same as the formula for the circumference of a circle. And that's something interesting to think about. We won't go into it now. I've got some other examples here. If k is 4t cubed, then dk dt, the derivative of k with respect to t, is 12t squared. If s is 5y minus 10y squared, then ds dy is 5 minus 20y. So just using the same rules that we used in the first video on this differentiation series. Also, you can see these things behaving like fractions. If ds dy is this, then dy ds, the reciprocal of both sides. If dk dt is 12t squared, then dt dk 1 over 12t squared. This is very handy stuff right here to understand that these derivatives can behave like fractions. Let's look at this example of using the chain rule. Find dy dx if y is 2x plus 1 to the power of 5. Now, in the previous videos we've dealt with polynomial functions, and if you were to expand this out, you'd have 5 brackets there, you'd have 6 terms, it'd be really messy, it'd take you a long time. But if you did that, you could do it, and then you could take the derivative of each term and you'd get the right answer. What we're looking at here is a much faster way of getting the derivative. So what I've done is defined a new variable u and said that's 2x plus 1. Okay, so I've said u is this part here. And then I've said y is now u to the power of 5. Okay, now I'm going to use the chain rule. I'm going to do the derivative of both of these. dy du, the derivative of y with respect to u is 5u to the power of 4. Just using the rules that we did before. Du dx, the derivative of this function u with respect to x is just 2, the number in front of the x. Okay, the derivative of 1 is just 0. So now we've got these two things, we can use the chain rule. Dy dx is dy du times du dx. So 5u to the power of 4 times 2. We don't want our final answer with u in it, so we go back to our original definition that u is 2x plus 1. So I'm just going to replace this u here with 2x plus 1. There it is there. Okay, 5 times 2x plus 1 to the power of 4 times 2, giving us 10 times 2x plus 1 to the power of 4. There we go, there's our answer. Much quicker and easier than multiplying out this big long bracket here. Even quicker, here's a formula for the chain rule. So we've got y is a function of x to the power of n. So this thing in here, in our last one, was 2x plus 1. And then we head to the power of 4, the power of 5, sorry, up here. So any function of x to the power of n. So remember the rule, you bring the number down the front, you subtract 1 from the power, leave that thing the same, and then you've got to multiply by the derivative of this function here. That's a very, very cool formula to know and understand. Here's an example using that formula. We've got 1 minus 3x to the power of a half. Remember, square root means power of a half. So using this formula that we've just learnt, what we can do, and notice here that you can't expand this bracket, you know, power of a half, square root. I can't make this any simpler. So this is where the chain rule really kicks in, really helpful. So I bring the number down the front, I subtract 1 from the power. Notice the 1 minus 3x stays the same. And then I multiply by the derivative of 1 minus 3x, which is minus 3. And then I've just got to tidy that up. Minus 3 is on the top, the 2 is on the bottom. 1 minus 3x to the minus a half becomes 1 minus 3x to the plus half on the bottom. Right? The negative index becomes positive when we put it down the bottom. And 1 minus 3x to the half is just square root. So this is a nicer way to write this last fraction here. Much nicer way of writing it. Same principle for this example. Bring the number down the front, subtract 1 from the power. Notice this thing in the bracket stays the same. Then multiply by the derivative of this function here, which is 2 plus 2x. A little bit of simplifying. 6 times 2 plus 2x is 6 times 2, so there'll be 12 plus 12x, or 12 brackets 1 plus x. Okay, so that's the simplest way that you can write that. Last example using the chain rule. This one's a little bit tricky. Y is 1 over x cubed minus 1. Hard to see how to use the chain rule until I do this first step here. So say that that's x cubed minus 1 to the power of minus 1. So I take that whole thing from the bottom and I put it up to the top. Now we can use the chain rule. Number down the front. Leave this in the brackets the same. Subtract 1 from the power. And then multiply by the derivative of x cubed minus 1, which is 3x squared. Okay, just to tidy that up, 3x squared stays on the top, the minus is out the front. X cubed minus 1 to the power of minus 2 on the top becomes x cubed minus 1 to the power of plus 2 on the bottom line. So there we've got our last one there using the chain rule. Very, very handy rule. You're going to use it a lot when you're differentiating functions.